this equation has two solutions. Yeah, I'm not joking. This equation actually has two solutions in the complex number system. Though in real number system, we all know that the modulus of sin x is less than 1, but in complex number it can exceed 1 as well. So let's see how do we find the solutions. Now for that, first of all, we need to be familiar with Euler's formula, which is something like this: e to the power I theta is cos theta plus I sin theta. Now if we substitute theta as minus theta, we get e to the power minus I theta as cos theta minus I sin theta. So that gives us e to the power I theta minus e to the power minus I theta is 2I times sin theta. And this leads us to the complex formula for sin theta is e to the power I theta minus e to the power minus I theta by 2I. So this is our new definition of sin theta for complex numbers. And using this, we can actually find the solution for sin z equals to 2. So now let's see how do we find the solution. Yeah. Now for this, we know sin z is e to the power I z minus e to the power minus I z by 2I. Yeah, is equals to 2. Now we can take 2I to other side. That gives us e to the power I z minus e to the power minus I z is equals to 5. Now we can write the e to the power minus I z in terms of the fraction. Yeah. And now we can take the LCM. That gives us e to the power I square z square minus 1, yeah, is equals to 4I times e to the power I z. Yeah. After that, we can have e to the power I square z square minus 4I e to the power I z minus 1 equals to 0. Now if we let y equals to e to the power I z, this is just y square minus 4iy minus 1 equals to 0, which is a quadratic equation. And now to solve this, we can use the quadratic formula that y equals to minus b. Minus b is 4i plus minus root under b square. Minus 4i square is 16 times I square, that's minus 16. B square minus 4, a is 1, c is minus 1 by 2a. 2 times a is again 1. Yeah. So now y is 4i plus minus root under, this is minus 16 plus 4, that's minus 12 by 2. Yeah. Now this is y equals to 4i plus minus, this is 2 root 3 times I. Yeah, this is actually 2 root 3 times I, because the square root of minus 1 is I and 2l is 2 root 3 by 2. Now if we divide by 2, we get 2i plus minus root 3i. Yeah, we get 2i plus minus root 3i. Now what is our I? I is e to the power iz. So e to the power iz is equals to 2i plus minus root 3i. Yeah. After that, we can take logarithms in both sides. That gives us iz equals to ln of 2i plus minus root 3i. And after that, our z will be ln of 2i plus minus root 3i by I. Now Now we can use the property of logarithms so that we can write it as ln of I plus ln of 2 plus minus root 3 by I. Now for ln of I is just e to the power I pi by 2. Yeah. And plus we can also write over here 2 pi I times k, because e to the power 2 pi I times k is just 1. So again e to the power I pi by 2 is I times 1 is again I. So we can write like this. This is just ln of I. So this is I times pi by 2 plus 2 pi k. Yeah, so that's why this is pi by 2 I times pi by 2 plus 2 pi k plus ln of 2 plus minus root 3 by I. Yeah. Now we are near to the end of solution. So this is pi by 2 plus 2 pi k plus ln of 2 plus minus root 3 by I. So basically I said there will be two solutions. So for principal value this k goes to 0 and we will just have two solutions, one for plus and one for minus. But for others there will be infinitely many solutions if we are not considering for principal value, because we can vary the k, yeah, and so the solution will vary. So in this way we have solved for the equation sine z equals to 2, and I hope you enjoyed the solution. This was basically the complex solutions. Yeah, I hope you enjoyed the video. Thanks for watching and look forward to seeing you in the next upcoming videos.